Hello student, we will discuss about the instantaneous velocity and instantaneous acceleration in one dimension. So average velocity we all know. What is average velocity? Average velocity actually average velocity is what? Total distance upon total time. But if we want to calculate the velocity at one particular instant, then we have to calculate the instantaneous velocity. For example, here we have 2 points. P and Q are the 2 points. Suppose this is xy axis, but here we have time t, and here we have position x. So at time t1, the position is x1, and at time t2, the position is suppose x2. So, and particle is moving like this. Particle is moving like this. So we can take two position. This x1 corresponding to x1, suppose the time is t1. This we will write t1, and corresponding to x2 we will take another time, and that will be t2 time. T2 time. This is our time axis, this is t. So this will be time interval delta t, and this will be delta x. If this time is 5 o'clock and this time is 5:30, so the time interval delta t will be of 30 minutes, and 30 minutes is very big gap. So we can calculate the velocity, but that velocity will be, we will get the average velocity, and this will be delta x, this will be delta t, this is delta x, and so average velocity will be delta x by delta t. Okay, this, but now see, if this time interval reduce, if we reduce the time interval, then what will happen? For example, if we reduce the time interval between points, curve is like this, motion taking place. Now one time is here and another time is here, very close. We can take on same graph even. So this is t and this is very small t1 and t2. See, the time distance will be very small now. Now this is delta x and this is delta t. This time, if it is 5 o'clock and it is suppose 5.01 minute, that means delta t is what? Delta t is 0.01 minute, and delta x, it may be anything. So average velocity equal to delta x by delta t. So what we are doing here, we are reducing the time interval. Earlier it was 5:30, now it is 5.0. If this t2, this point is p and this point is q, if this time interval is very small, suppose if we extend this point here, so what will happen? If time interval delta t tends towards 0, the q will be here. We can take number of position of q. So if time interval is very small, so this point will turn very close to q. Initially it is, and then finally it is, this time is t, this is x1. If this second time, first time is t1 and t2 is 0.00001, t1 is suppose it is 0. So what will be the delta t? Delta t will be 0.00001. So this point, if it is p, it is q, q will coincide with p, and we will get one tangent here. So the velocity at one particular instant. This you can say, and then delta x will be also very small, and delta t will be also very small. So when delta x and delta t both are very small, here we write limit del t tends towards 0, it is v velocity, this will become dx by dt. The differential coefficient of velocity displacement with respect to time is called the instantaneous velocity. It is the velocity at one particular instant. Actually, velocity and average velocity as such no concept. Generally we say ki velocity and average velocity both are the same thing. It is the instantaneous velocity. Whenever we calculate the velocity, we calculate the velocity at, for that we require the total distance upon total time. But if we want to calculate the velocity at one particular instant, we require differentiation, and this is called the differential coefficient of time, differential coefficient of x with respect to t. It is called instantaneous velocity, and this differential coefficient we can calculate by using different formula. This is, for example, there are number of formula d by dx of x square. So it will become what? 2x. Basic formula for to calculate differentiation of any function. Suppose the function is x to the power n, it will become n x to the power n minus 1. This is the basic formula. Now suppose if the function is given like this, if x equal to given 4t square plus 2t, then what will be the velocity? Left hand side will become dx by dt, right hand will be d by dt of 4t square plus 2t. Then write it in split into two part, d by dt of 4t square bracket close plus d by dt of 2t. 4 is constant, take it outside the sign of differentiation, t square plus 2 is constant, d by dt of t. Here we can apply the formula, and that is x to the power n, it is equal to n x to the power n minus 1. So here we will apply, but this time the differentiation with respect to time. So it will become 4 into 2t to the power 2 minus 1 plus 2 its power is 1, so it will be 1t to the power 1 minus 1. It will become 8t plus 2t to the power 0. Something to the power 0 is 1, so it will become 8t plus 2. It will be equal to dx by dt. Dx by dt, that means the velocity. So the velocity will be this. And we have already calculated this. And for that we need the different types of function. Suppose the different functions are what? D by dx of sin x. D by dx of sin x, it is cos x. D by dx of cos x. D by dx of cos x, it is equal to minus sin x. D by dx of e to the power x, it is equal to e to the power x. And d by dx of x to the power n, this is the actually first formula, n x to the power n minus 1. Remember, if it is x, it must be x. If it is x, it must be. If it is t, it must be t. For example, d by dv, and if it is v square, so what it will become? 2v 2 to the power minus 1, it will become 2v. So velocity equal to dx by dt. Here velocity is a function of what we can say. The velocity is a function of x. Velocity is a function of x. If x changes, velocity will also changes. By using the same consideration, we can calculate the instantaneous acceleration also. Now, what is the acceleration? Suppose if you want to calculate the acceleration at one particular instant, then that instantaneous acceleration also we can calculate. Instantaneous acceleration. So to calculate instantaneous acceleration, draw one graph, and that graph will be velocity time graph. Instantaneous acceleration is given by, suppose the particle is going like this, its velocity is here v, and here v plus delta v velocity, and here time is t, and time t plus delta t. If the gap is too much, then we will get the average acceleration. Suppose this time is 5 o'clock and this time is 5:30, so the time interval is 30 minutes. So in this case, we will get whatever we will get acceleration, the final velocity minus initial velocity upon time. So it will become average acceleration delta v by delta t. So one velocity is 5 o'clock and one velocity is 5:30. So that acceleration is called the average acceleration. But if it is asked what is the acceleration at one particular instant, so for that we have to reduce the time interval. Now, how to reduce? Again, you can go by the same process. Suppose the time is, one time is t, 5 o'clock, and second is 5:30. So the gap is 30 minutes. Now, if you can take one more time here, so that will be 5:10. If you can take one more time here, it is 5:01. So what will be this gap? This gap will be 0.01. Further, in differentiation, this gap, if it is this point is, this time is 5, and second t1 is suppose 5, and t2 is 0.0000, means 5.005. So what will be delta t in this case? In this case, delta t will be 5.0005 minus 5, 0.0005. Very small time interval, and it is approximately equal to 0, or very close to 0, tending towards 0. So acceleration limit del t tends towards 0, delta v by delta t. When we write like this, it becomes a equal to dv by dt. This is called the instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration. So we have two acceleration. One is average acceleration. This is average acceleration. Average acceleration. So those who are asking now, what is instantaneous? Instantaneous means at one particular instant. And so both the things here, what will say that instantaneous acceleration, it is what? It is the differential coefficient of velocity. Now both the things are like this. Acceleration is what? Acceleration will be the function of velocity. Acceleration is function of velocity. We can say acceleration is dv by dt. Now velocity may be anything. Suppose velocity is like this, 4t cube plus 70. Now what will be the acceleration? Question है, suppose if velocity equal to 4t cube plus 70, what will be the acceleration? So what will be the acceleration? What will be the acceleration? So we have to put this value here, since acceleration a equal to d by dt, and what is v? 4t cube plus 70. It will become, then one function is 40 cube, one function is 70 cube. We can write d by dt of 40 cube bracket close plus d by dt of 70. Then this 4 is constant, you can take outside, d by dt of t cube plus 7 is constant, d by dt of t. Now if it is t, the differentiation is possible, and we have very simple formula for that, d by dt of t to the power n. if it is x, then we can write n x, so it will become n t to the power n minus 1. Same formula depending upon the with respect to we are doing the differentiation. So here we will do the differentiation with respect to time. T cube, it will become 4, t. Now power of t is 3, so that n is 3, so it will come here t 3 minus 1 plus 7. Now what is the power of t? T is 1, so 1 t to the power 1 minus 1. It will become 12t square plus 7, only 7, because t to the power 0 will come and that 0 will become 1. Hence the acceleration will be this. Like this we can calculate the acceleration for any function. Now see, we can develop acceleration from the simple displacement, from the displacement equation. For example, if x is equal to given, if x is equal to 4t cube minus 7t square plus 35, it is given. So what will be the acceleration? What will be the velocity and acceleration at t equal to 1 second? At t equal to 1 second, this we have to calculate. So how to calculate that? To calculate that, first of all we will differentiate with respect to time, dx by dt. This will become d by dt of 4t cube minus d by dt of 7t square plus d by dt of 35. Remember 35 is constant, so its differentiation will be 0. This will become 4 d by dt of t cube minus 7 d by dt of t square and plus 0. Why 0? Because here t to the power is 0. So it will become 4 into, apply the formula here. Which formula? Since the variable is t, so we can write d to the power tn. It is n t to the power n minus 1 formula we will use. So power is 3, so 3 t to the power 3 minus 1 minus 7, power is 2, so 2 t to the power 2 minus 1, and it will become 12t square minus 14t. Now where to calculate the velocity? This is velocity. But when to calculate the velocity at t equal to 1 second? So we will put t equal to 1 second. At t equal to 1 second, v equal to 12, 1 minus 14, 1. So it will become 12 minus 14. The velocity is minus 2 meter per second. Don't worry while writing the negative sign. The velocity may be negative, velocity may be the positive. So we have calculated the velocity. Now one more thing is asked here. What will be the acceleration at t equal to 1 second? To calculate acceleration, we have to differentiate velocity. So to calculate acceleration, we will keep this here. Now see, what is velocity? Velocity is 12t square minus 14t. So acceleration is given by dv by dt, and velocity we have calculated. Velocity is what? 12t. What is velocity? 12t square minus 14t. So we'll write 12t square minus 14t. Now this velocity we will put here. A equal to d by dt of 12t square minus 14t, then split into, means write separately, d by dt of 12t square minus d by dt of 14t. This 12 will be outside. D by dt of t square minus 14 d by dt of t. Then it becomes 12 t square. It becomes 2t to the power 2 minus 1 minus 14. The differentiation of t is 1. It will become 28t minus 14. acceleration. And when to calculate the acceleration? At t equal to 1 second. So to calculate acceleration at 1 second, put the value of time is here. It will become 28 minus 14, 14 meter per second square. This is the acceleration and velocity in one dimension. This is the velocity and acceleration in one dimension. Now we will develop in next video how to go with instantaneous velocity and instantaneous acceleration in two-dimension motion. Only thing is what in two-dimension motion we will define in two-dimension motion both the things we will define. That means r we will define r equal to xi plus yj. V will define vxi plus vyj, and ta will be axi plus ayj. So that average velocity also in two dimension as well as average acceleration in two dimension motion. Let us see before we will see next time that. Thank you.